All right, today we're diving into a project that is, frankly, mind-bending. It doesn't just try to make computers faster, it completely rethinks what computation even is, right from the ground up. This is the story of REZON.
So let me just start with this question. For the better part of a century, every computer you've ever used has been built on one simple idea, a switch. It's either on or it's off, a 1 or a 0. But what if that was just one way of doing things? What if there's another path, one that uses the flowing, continuous physics of waves to actually do the thinking?
And that question leads us straight into this new computing paradigm. We're talking about a move away from transistors and rigid logic and into a world where logic is built from the beautiful dynamics of oscillators. I want you to picture a whole orchestra of tiny, interconnected clocks, or maybe metronomes. Now, in this system, information isn't just a simple on or off. No, it's stored in the phase of each clock, its exact position and its rhythmic cycle. It's an infinitely richer, more analog way of holding on to data.
Okay, but this incredible idea came with a huge challenge. I mean, if your computer is basically a symphony of interacting waves, how in the world do you get it to perform reliable, stable logic? How do you get it to give you the right answer every single time?
The big test, the crucible really, was to build a CNOT gate. This is a fundamental building block of computation. If you can build a stable CNOT, you can pretty much build any computer you want. But the first tries, using just the raw physics of these oscillators, well, they were a complete disaster. The results were chaotic, unpredictable, totally useless. And this slide really lays out the dilemma they were facing. On the left, you have the pure physics approach. It's beautiful, it's elegant, and it had a 0% success rate. So on the right, they tried a workaround. They slapped a machine learning model on top to try and make sense of the chaos. And hey, it worked. It gave 100% success. But it felt like a cheat, It was a black box crutch that didn't actually solve the fundamental problem.
So the whole project was basically at a dead end. But then came the breakthrough. And it wasn't some new piece of hardware or fancier algorithm. It was a moment of pure mathematical insight.
The solution was discovered and invented by one person, Christoph Vusch. He looked at this mess not as a hardware problem, but as a flaw in the fundamental equations governing the system. And so, he derived a new one.
And here it is. This is the equation that changed absolutely everything. Now, you don't have to be a math whiz to see the magic here. It's all in that middle term, that cosine of the control oscillator's phase. It acts like a perfect, physically grounded switch built right into the math.
The elegance here is just wow. Look, if your control bit is a 0, that cosine term is positive. That forces the output oscillator to synchronize with the target. It just copies its state. Simple. But if the control bit is a 1, that cosine term flips negative, and that forces the output to anti-synchronize, to go to the exact opposite phase. It flips its state. And that right there is perfect CNOT logic, emerging naturally from the physics.
And the result? 100% success. Not 99.9, not close enough. Perfect, deterministic, reliable logic every single time, proven over and over across hundreds of tests. This chart just says it all. The old method is flat on the floor at 0%. The new CNOT phase gate, a perfect 100%. But look at that third bar. That's with a massive amount of noise injected into the system, and it still gets a perfect score. This thing isn't just correct, it's unbelievably robust.
So this was way more than just a clever hack for one type of logic gate. This was the key that unlocked an entire universe of computation.
He immediately realized this core principle was universal. He could use the same basic idea, using the phase of one oscillator to control the interaction between others, and by just tweaking that mathematical function, he could derive the equations for every other fundamental logic gate. And here's the proof in the pudding. Not, and, or, XOR, NAND, NOR, the whole shebang. The entire toolkit you need to build any program you can dream of. Every single one derived from the same core physics, and every single one verified to work perfectly.
So, what's the big takeaway from all this? The bottom line? The system is Turing-Complete. That's a fancy way of saying that with enough memory, this phase-based computer can solve any problem a regular computer can. It is a true universal computing machine.
So what does this all mean for us? What are the real-world implications of having an entirely new Turing-Complete way of computing things?
Well, first you have to understand this isn't just new software, it's a whole new philosophy for hardware. In this computer, the answer to a question isn't calculated in a sequence of steps. Instead, it just emerges. It's the most stable state, what physicists call an attractor, that the whole physical system naturally wants to settle into. Think of it like a marble always rolling to the lowest point in a bowl.
And when you start thinking that way, the potential applications are just staggering. You could have neuromorphic chips that work more like our own brains, new ways to tackle those ridiculously hard optimization problems. We could even build all optical computers that use light instead of electricity. It might even give us brand new insights into how our own brains work.
Now, here's what I think is the absolute best part of this whole story. This isn't some secret research locked up in a corporate lab. You can dive in and see it for yourself right now.
That's right, the inventor, Christophe Gouache, has made the entire REZON project completely open source. He's put it all out there for the world to see, to verify, and to build on.
And I mean everything we've talked about today. The deep mathematical proofs, the actual simulation code that got those 100% scores, all of the benchmarks. It's all there for you to inspect. This is how science should be done.
So I'm serious, go to GitHub. The repository is chris0mecom/REZON. That's KRISSS0MECOM, all one word, /REZON. You can actually download the code, run the simulations, and see this new form of computation come to life on your own computer.
So we'll end on this thought. For decades, we've been trying to force physics to bend to our rigid model of logic. But what the REZON project shows is that logic can just emerge from physics itself. It kind of makes you wonder, doesn't it? What else are we looking at completely backwards? What other huge breakthroughs are just waiting for us to change our perspective?